All right. Well, thanks everyone for joining. This is our first Bits and Bytes session. We're going to be talking about vector augmented labeling classification today. My name is Gibbs Cullen. I'm a product marketer here at Pinecone, and I'm joined by Christopher Amata, who is a senior SE. And so we're excited to talk to you guys, and hopefully you can learn a little bit something new today. All right. There we go. So just before we get in, I wanted to give a little context for what Bits and Bytes is and what to expect moving forward. So this is a new online webinar series where we're going to be exploring the many different possibilities and use cases for Pinecone in AI. So obviously this one's going to be on classification, but future sessions will dive into, at varying levels of depth, other use cases and solutions like candidate generation, multimodal search, vertical specific use cases, and more. So the next couple sessions will still be focused on classification, where we'll go into some deeper dives, like around data curation, active learning, and things like that. So make sure to keep an eye out in our community center where we host and list all of our events. And make sure to follow us on LinkedIn and Twitter, as we will post new events there and reminders as well. But overall, the goal of these sessions are to help you kind of learn a little bit more about what's possible with Pinecone and help you kind of leave with some bits and bytes of some information that you can apply and practical learnings that you can apply to your existing or new AI use cases with Pinecone. So a little bit about the agenda for today's presentation. We're going to start out giving an overview of the world of unstructured data and kind of how Pinecone and vector search fits into that. Then we'll get into an overview of Pinecone serverless and how that is uniquely positioned to solve for some of these use cases that we're going to be talking about today. And then Chris will be giving a live walkthrough of a multimodal and semantic search and classification use case with Pinecone. And at the end, we'll leave plenty of time for Q&A, but just as a reminder, there is a Q&A section in the webinar. So if you have questions during the session, put them in there. We have people from the team online as well who can help answer during the session, but anything that doesn't get answered during, we'll leave to the end for us to cover before we wrap up. And then we are also recording the session, so we'll be adding it to our YouTube channel and then sending out the recording to everyone on this talk afterwards. So without further ado, I'll pass it over to Chris to kind of jump into the next part here.
Awesome. Thank you, Gibbs. So as Gibbs said, we're going to have a little bit of fun today. The real goal of all of this is just for everybody to get little bits and bytes about some new ideas and kind of new ways to utilize a lot of this technology. So before we go into really specifically exactly what we want to talk about, I think it makes a lot of sense to just look at the whole world as a macro and start to dig into why some of these technologies are so uniquely fitted to take on some of these problems we've been trying to solve for quite some time. So Gibbs, if you don't mind going to the next slide for me, right? The world and the businesses and the enterprises and just everywhere is full of truly unstructured data. And when we think about unstructured data, what are we talking about? We're not simply just talking about pure PDFs or pure text. We're talking about all of the videos, all of the audio, all of the sensor data, any piece of data that we've been collecting. And there's a ton of statistics out there about people talking about the big percentage of this, but the overwhelming majority of the world's data is unstructured. And one of the most exciting things about this huge, foundation generative AI boom that we've seen is the ability to not only work with a tremendous amount of data, but to be able to create even more of that data and utilize that downstream. So for this session and for this webinar series, what we really want to start digging into is how can we, as just a whole ecosystem of developers, engineers, thought leaders, start to tap into some of these modalities with social media videos, with streaming data, with any new piece of data. We have models and we have infrastructure in place to start really working with this. And this is going to provide a whole new set of insights that we can unlock to the business. So this is where we really want to start, is just saying at a high level, when you think about vector databases, when you think about vectors, when you think about transformers, when you think about all of these things, we really want to start looking at the large scale multimodal world and saying, hey, these are really unique tools that can help us solve these types of problems. So Gibbs, if you go into the next slide here, obviously we're excited and you're going to get a lot of excitement because this is what I really want to dig into. But when we think about what types of data there is, I just wanted to provide a couple examples here. And you're going to get a big gist or a big trend from this whole presentation, as I definitely won't be reading from a lot of these slides, more having this be conversational. But if you think about purely unstructured data, a pure TikTok video is so rich in content, right? Because there is audio, there's multiple versions of audio, there is talking to, there might be a sound in the background, there might be songs in the background, there's a full video with maybe fits, with dynamics, with movement, with energy. There's things that can be captured, as well as the actual transcripts, the language, the audio that we can pull just from this one piece of data. There is so much that we could understand, derive insight from, work with. At the same way, a lot of unstructured data has historically been used for viewing and has really been stored just in blob storage. It has been really challenging to work with. So video data historically, long videos have needed to be broken into frames, have needed to be broken into tools. We can start to work with all of this at a much more efficient way. And this is a very exciting process. So obviously there are some specific pieces of information, but in every single business and in every single use case, unstructured data is everywhere. And what we're really trying to dig into is now this data can be utilized downstream.
Okay.
Gibbs, do you mind going to the next one
Yeah.
here? Yeah. So this is where I think I wanted to start talking a little bit more about what the impact is. And again, the whole goal of this session and these sessions, right, there's going to be multiple ones, as Gibbs talked about, is to lay a foundation. So for further sessions, we might dig into one of these use cases, but we really wanted to start kind of thinking and feeling about what's possible. So product search has been awesome because we've taken products and we've taken these into keywords and we've broken these in. But for a now kind of novel time, we can turn all of these products, the images, the descriptions, and we can start using these in a new and novel way when we're looking at the content that we're working on, right? Even with a common RAG application or just any type of different content systems, there's not just text here that we want to work with. There's going to be recordings of people. There's going to be sales calls. There's going to be documents. There's going to be charts. There's going to be GIFs and images and all different pieces of data. And we can do a lot with that. If I'm asking a question about how to fix something and there's a video to go along with this, this video can now help me even more so than just being able to tell me. Or, and what I think is a really exciting feature is until about now, asking a question about a movie and looking for certain frames in a movie, or asking a question about an edge anomaly from my detection model has been brutally challenging. And this is what we can start to do if we can unlock unstructured data. And, this is going to be, without a doubt, I think the simplest architecture slide that anyone will ever see. And it's definitely designed that way. So hopefully this isn't turning anyone off from the simplicity here, but this is really at the core why there is a tremendous amount of value in working with unstructured data in a vector way. Because if you can take data and utilize data and turn it into vectors, everything that we're about to talk about is going to start to be unlocked. So yes, there is a beautiful world where we can start to build all these different systems. And with these systems that rely on images, the voice, full document enrichment, the text, data, sensor data, satellite imagery, I can keep listing unstructured data cases. And if you can think about this in a vector native way, there are an entire world of AI applications that have historically been very cost constrained and very hard to unlock. And doing vector search and pulling things from a vector native approach is going to unlock massive, massive parts of these use cases that we believe can start to unlock more developers and more teams building. Again, this is an architecture slide that is looking at what is possible with vector search, not simply that this is going to be everything that is going to happen. And Gibbs and I were talking a lot about, thinking about all of the different things that we've heard. And Gibbs has been here for a couple of years. I've been here for a year myself. And the amount of AI use cases that are coming in and out of Pinecone are coming in and out of just the entire ecosystem as a macro, right? Taking ourselves out of this are amazing. We listed just a quick 25 or 30 as fast as we could. But when we start to dig in and think about what's being unlocked, teams can start to really dig in to really tap into full generative AI. I can really build, anything around content, but we're also starting to see really unique kind of operational tools where I can take a log and log data can be treated as a vector, as a representation. And in the same way that I might want to classify and curate data for an edge case, I can start to classify and curate anomalies in a much more efficient way. And what Gibbs and I want to start to do is for the next 15 minutes after we get into some of these possibilities is really drive into what makes Pinecone really helpful in all of these. And just for the last minute, thinking about what Pinecone will allow us to do is set up a place and a process and a workflow that is going to help us take a data-centric approach for all of the use cases we're talking about. This is the excitement here, is not that anomaly and outlier detection is completely one-off from a log-based anomaly detection. There is a real way that you can build and design workflows that are going to help solve the biggest bottlenecks in these designs. And this is why, if you design these workflows, all of these places and all of these tools will kind of be in place. So Gibbs, I think, yeah, Gibbs, if you want to take this one, or is this one is mine as well here?
Yeah, I mean, I think we can, tag team this one, but I think this kind of going off of, you just kind of set the stage for all the things that are possible. We barely even touched on the surface with that big list on the previous slide, but I think kind of bringing it back to Pinecone, and kind of these classification and labeling use cases, I think we tend to see these four characteristics or these four buckets of features with the top I guess AI use cases that we work with at Pinecone. So so I don't know, Chris, if you have anything else to add to this.
Exactly. And I think what if we go back from the last couple of slides and all of these things, all of these use cases, as I said, we could start to build a common workflow for. And this is consistent because of these four things here. What I'm really starting to kind of point, or what the team is starting to think about, is all really multimodal AI use cases, whether this be building a detection algorithm, whether this being anomaly detection, whether this being content moderation. These have these characteristics. The data set is truly, truly large. And when we're talking about large, right, billions of vector scale, millions, hundreds of millions. And this data is going to be truly multimodal, whether this is going to be purely just an image, whether this is going to be an actual document that's enriched with multiple pieces of data, with video, with imagery, with, Jira tickets, fill in the blank. But also, this data is really dynamic, it's diverse, it's complicated, and we need to have answers as quickly as we can. So we're going to use these core four features that we've seen across AI use cases and talk about why you need specialized tools to tailor solutions for these problems. Dynamic, large, changing data sets are a very, very difficult beast to wrangle. But for the first time, we really believe there are tools in the market that are there and ready for teams to take over and solve these four challenges, or these four themes.
Yeah. And so now I kind of going off of that, now we have kind of the foundation set. I want to give a quick, high level overview of Pinecone serverless and explain why and how Pinecone serverless is uniquely positioned to solve for these types of workloads that we just described on the previous slide. So for those of you who aren't aware, we announced Pinecone serverless back in January in public preview. It recently went GA on AWS back in May. But this was a huge effort, and it's a completely reinvented architecture of our vector database. And part of the reason or motivation for rebuilding this and re-architecting to offer this new serverless solution was, I think we kept seeing and observing and from our users, our customers, from the industry, that there is this limitation with existing tooling, legacy tooling, or non-purpose built tooling that where being able to search over large amounts of data on demand and cost efficiently just didn't exist. I think with more traditional databases and ones that were not purpose built for vector embeddings, we would see that the cost would become quickly prohibitive or not efficient at all as you're trying to search over these large corpuses of data on demand. So we decided to rebuild the vector database to be able to partially to be able to address this limitation, solve for this limitation, and basically deliver a solution that provides up to kind of 50x cost savings, at least compared to our pod-based architecture. And this is due to our decoupled architecture of our serverless offering. We were also able to deliver kind of low latency, fresh data, high recall with our proprietary indexing and clustering algorithms. And then finally, we're able to continue offering this fully managed service on top of a truly serverless experience so that you kind of have hassle-free and effortless scaling. So this is kind of why we decided to build a brand new database, to build this serverless architecture, and how that these things can kind of help solve for these types of workloads that Chris was talking about earlier. So I'm going to get a little bit more into each of these buckets here, explain a little bit more how classification and those types of workloads can really benefit from these features. Yeah, so the first one, kind of getting into a little bit more of the decoupled architecture. As you can see here, we have on the diagram, the architecture is kind of broken out by the read and write path here. And this really is great because it enables you to independently scale your compute resources, so your reads, your writes, and then your storage. And this allows you to be able to meet the varying demands of your different AI workloads while also keeping your costs low. This also means that because it's separated and decoupled, you really only need to pay for what you use and like the storage you use, the compute you use, and you're not paying for any like idle or compute resources. And this is really great for these classification workloads, right, Chris? Like as we were talking about earlier.
Exactly. And when we're talking about all of these types of workloads, right, Pinecone isn't solving every single piece of the puzzle, but when we're looking at it from the data point of view and the problems that are in these workloads, this is where there's a huge impact, right? If I decouple my architecture out and I can take advantages of object store to store these vectors and store the affiliated unstructured data with them, this now means that I don't necessarily need to keep billions or hundreds of millions of things that I might not always need to use in my process. So imagine if I'm building, right, a self-driving vehicle, or I'm trying to build anything that's autonomous in some way. A lot of the data that I'm working with is not totally useful to me trying to build my model, trying to understand. If I'm going through and trying to build this, I'm really trying to find unique examples, unique instances, unique events. And the majority of times, it's not really unique. I'm in a car that's taking a lot of pictures. However, I need to be able to search through these pictures to find the uniqueness in this. And when we've decoupled this out, I actually have the ability to use this data. And, I don't know what's in all of this data, but it is in the storage. And as I start to query it, this is going to pull from that, a cost-effective blob storage and pull it into where it needs to be very effectively actually queried, classified, or curated. And I think that's what makes this so exciting is when we set out to build this architecture, right? There is a very important problem that this large dynamic data set is built not only for the use cases that are apparent right now, but for these types of unstructured data use cases, you need to be able to not just store that data, but work with it here.
Yep. Yeah, and on top of that, we have these proprietary indexing or clustering-based algorithms that help with making the queries extremely efficient, resource efficient. As you can see here on the diagram, you kind of like things are going to be clustered in a way that brings the most relevant or only the most semantically similar data together. And so this helps to, and this is done adaptively. So as new data comes in, things will adaptively recluster to make sure that it's optimized for low latency, high recall, all while maintaining like your low costs. And on the query side, this is great because you're only going to really need to like page the necessary partitions for your query instead of like scanning everything that's in memory, which is like the more traditional scatter gather approach. So this makes for everything to be extremely resource efficient. You keeps your query latencies low, your data fresh, and then your results highly relevant at all times. Anything else to add there, Chris?
Yeah, and if we, take a step back and talk about an anomaly detection use case, these things we're trying to dig into, right? Trying to apply some concepts. If we look at this chart, we're already starting to cluster the data solely by building an index. By using this and clustering the data in this effective way, I'm putting data in similar groups so that I am going to be able to retrieve the similar data. So if lots of data is in a similar cluster and there is a very few pieces that are going to be out, this index is going to help be built that way. So when I query effectively, not only am I going to have these efficiency gains that Gibbs talked about, but I'm simply going to be interacting with a database that has really prepared the data in a way that is ready for me to communicate and interact with it.
Yeah. Yeah, and finally, kind of going back to that last point on being a fully managed and truly serverless user experience, this kind of means that you don't need to worry about provisioning or managing, or even really, you don't even really need to think about your infrastructure. We'll kind of handle all of that for you. And if you're familiar with our pod-based architecture, with serverless, this means you have no more pods, no more replicas to configure, resources to start a provision. It kind of is all managed for you. And so with serverless, it's super simple to get started. You basically just need to name your index, load your data, and then you can start querying almost right away. And as you can see here, we have this kind of built-in multi-tenant query or compute layer, which is really how we power our multi-tenancy use cases and workloads. And you can basically power kind of highly efficient retrieval over like thousands of your users, all of your users and tenants on demand. And this can be achieved with things like features like namespaces and metadata filtering. Namespaces in particular are extremely powerful. They help really partition your workload into various tenants or classes or topics, kind of however you want to split up your workload, and will isolate that segment of data within your index so that you can kind of query by namespace. And this is also a really great feature and benefit when you're trying to build out these classification workloads. All right. Anything else before moving on, Chris?
No, I think there's some great questions from the audience too. So I know Gibbs and I want to save
Oh
some
yeah.
time.
Okay. Yeah, I
So
see them coming in.
yeah, so please keep coming, for
Yeah.
sure. And just on that, right, this is what we're trying to at least do, and we're going to get into some more specifics at the end, is just think about the core fundamental Pinecone capabilities that teams are really familiar with, and build an understanding of where these can be applied across different AI initiatives in the org.
Yeah.
Just like name and metadata, another great capability. It's a good one to bring up,
Yeah.
Gibbs.
Yeah. Yeah. So hopefully that kind of sets that again, that was a high level overview. We have many more resources on serverless, but that's kind of setting the stage for kind of how Pinecone serverless is uniquely positioned and purpose built to kind of address these workloads that we've been talking about this whole time. On that note, we're going to turn it back over to Chris. He's going to give a walkthrough, kind of to tie everything together of what an example application might look like that combines this multimodal semantic search and classification together.
Yeah, and this is going to be exciting because what we're going to do here, and we're going to spend the next, let's call it 15 minutes or so, conceptually thinking about, a very simple, exciting kind of application idea. Unfortunately, we're not going to be digging too much into a demo just for the sake of time. Some later sessions will be full demonstrations of what we're trying to do. But if we go to the next slide, I just because it's Tuesday morning, right? It's exciting, and we're going to think about not fraud detect. We're not going to think about anything boring. We're going to think about dogs here. So
Okay.
Gibbs,
And do you want me to
don't
turn
mind.
it over to you to share?
Yeah, I'll take the
You have
screen.
multiple tabs, right?
Yeah, I'll take a screen share.
Okay.
Set this up. Maybe I can do some stand-up comedy um, in the meantime here. Oh, can you stop sharing real quick, Gibbs? We're
There we go.
sorry, Zoom
Very good. All
nice.
good. All
Thank
you
you for
know.
the pick, team. All right, I think we're good to go here.
Yep, all set.
Sweet. So I know this is going to be really simple and a little bit silly maybe, but this really is designed to be high level and a little bit thought provoking. So I love dogs. I love animals. I think it's a really good way to start to think about what we can represent with unstructured data and how we can apply it to many different business outcomes and the goals. So, I'm going to put together and walk us through a very basic example. If I wanted to build an app that we could call something like Paw Finder, right? And what the goal of this would be is to work with build an actual application that has an index of all these different types of dogs that people can come on, upload images of their dogs, look for certain pictures of dogs, and be able to query throughout and find this. It's actually a little silly. I live in San Francisco, a super dog friendly place. I'm always looking for different things for my dogs and just, have a couple searches here. But if we think about this really quickly, this is actually, it seems from a very high level, somewhat of a complicated use case here, because I'm going to have to find a bunch of pictures of dogs. We're going to have to go through, we're going to have to abstract and figure out which dog's a golden retriever, which one's a lab, fill in the blank. I have a rescue mutt that's got 6 or 7 different types of, kind of breeds in him. So there's no way that I could ever go and look up just a certain dog breed that would be there. So the first thing that we would have to kind of come in and start to do, excuse me, is actually go and collect data. So this is in the first place where I want people to start, where I want Pinecone to have a kind of voice in this is the world is full of great data sets and the internet is amazingly full of something like this. So if I wanted to build an application like this, the first thing that I could do is I could go and start to look at web data. So for this example that we're going to go through, we could start actually using something like the Layon data set. We could start to actually pull Google Images. We could go through and actually generate pictures as well. So I wanted to go through and start to think about this. So in Pinecone, what you can do is you can download the data. You can embed this. And again, this isn't dog data with Layon data sets. This is what we're going to talk about. You could take all of this, you could pull this as a vector, and then you could upload this. Now, inside of this data set, there is a lot of different data. There's dogs, there's scenes, there's vacations, there's, listings, there's stock images. I don't need the majority of the data, or the majority of the data is not particularly useful to the business or to the application or to the problem I'm trying to build. So we all know that Pinecone at its core is going to be able to do multimodal search very well. So that's the first place I can start with is I need to find particular instances of data. I need to go out and I need to find golden retrievers. I need to find labs. I need to find Wheaten terriers. I need to find fill in the blank. So I can start there and start to pull out my data set. And I can use Pinecone and I can actually curate the correct data here. So I could do simple multimodal search, whether I wanted to search it with text, whether I wanted to give it a specific image. I can do any of that. I can then upsert this and I can start to curate out the right data sets. And this is where we're going to start just building out right away, because now I would be able to have an index that would be full of data that would be multiple dogs, different types of animals, different breeds, fill in the blank. So if we stop for a second and think about the value of that, the machine learning ecosystem in the AI space is full of painstaking curation use cases, right? And this is where Pinecone is going to start to lean in and really be a helpful hand. When I first started building applications, I was working at an insurance company trying to build a roofing detection algorithm, right? And the big problem in this roofing detection algorithm was not predicting roofs, but it was predicting mansion roofs, because the majority of the training data set that I had available to me, was basically all the same. If you think about the continental United States, the majority of roofs look very similar. So we would go and we would take data, we would train, we would train, we would train, and then sure enough, it would still not be able to predict on the properties or the things that mattered. And this is really important because if I was able to predict on more, ski houses, mansions, other things like that, they would be able to come out and insure. And this is the same simple process of starting to build an application like Paw Finder, where I was saying, hey, I'm going to take a public data set. I'm going to start to curate out to find the right pieces of data that I need. Just like my problem in when I was back in the insurance world, my problem was not necessarily going and predicting the actual roof, but what it was is it was finding the right roofs that pushed my model to the right way, or that it went through and actually, found data that mattered to the business. And this is where, if we take a quick pause on all of this is where business use cases are flooded with these problems and these pain points, right? If we are thinking about first party cookies are starting to go away, the ability to start to collect kind of information around it is going to be becoming much harder. So we can start to leverage more multimodal data, more imagery, more social posts, things like that, and curate out things that we need to find. If we're actually building, right, a data-centric object detection algorithm, a segmentation tool, a self-driving car, any type of real kind of computer vision system, a lot of the problems finding the right data sets to work with. Furthermore, if we wanted to actually go into, building out a beautiful RAG system as well, a lot of ML is still putting good in, getting good out. So I can simply start to find similar pieces of data that I know my customers would find a good answer to. If it's, simply from a search and recommendation, if we know pieces of data are trending better, are doing better, we can find that through this. And this becomes a really fundamentally important process, because Pinecone is not going to be predicting on something or building a full end-to-end detection tool, because that is really solved by so many of these transformers that are out in the world. But what we keep seeing time and time and time and time and time again, going back to the dynamic types of data and all of this, is that all of these use cases are swamped with really messy, difficult, large amounts of data to work with. And if I can, for just one time, be able to curate efficiently without spending money, without having to bring in human intervention, without having to do any of that, and then build better systems downstream, there's a huge impact. And that's really where we're getting at. So I talked a little bit about, kind of like looking at, hey, how can we set this up? So there's a very simple architecture, and we're going to get into a few architecture slides and keep talking about this. But for this peer curation use case, right, this is how we can start to build this out. You can start to take data and you can start to build unstructured. So Layeon is a great example because it's truly a multimodal unstructured set. This contains image and text pairs, it contains captions, it contains a bunch of information that's really, really, really quite interesting. So you can take this data and then we can use other types of vector models, right? So a lot of encoding models that we're familiar with might be around just text encodings, might be around there, but there's a whole world of truly multimodal models which can take in different types of data inputs and create vectors from this. So this is what we're talking about here, is we can use something like Clip. Clip is a fantastic model. It has been out for a while. It is the underlying model that has built a lot of successful multimodal tools out there. And you can take any piece of unstructured data, right? I used a public data set of Layeon. I also am able to pull in files, or I'm also able to web scrape videos and use the same process. I can take Clip and process the text and images. And then, we're very familiar with how the Pinecone mechanisms start to come. And with this, I can take this data and I can store it in a file that Pinecone uses. We're using Parquet here, but this is where Gibbs now is started to kind of talk about some of the features and capabilities. This is where this becomes really important, right? So I have my image URL, I have my raw unstructured piece of data that we're talking about, the vector, but I also have the capability to start to add all of this metadata. So if I had a label for all of these, I can apply a label for my metadata and then start to query that and extract just my metadata to fill in new labels. If I have captions like I do here, if I have combos, if I have things like this, I'm able to retrieve these and present these right away. Now, this pipeline right here for kind of doing multimodal search, again, is very simple, but we're going to talk about the true mechanisms of what's going on here. So I have this picture, of a pine cone. We have a frame of Batman. In the example for Paw Finder, right, just to think about creatively, it's a picture of a golden retriever. Any of these pieces of data can be turned into a vector, which can then search all of the unstructured data that we now have represented in Pinecone. And this is really, really powerful because I can go and use a multimodal model and start to query on this using language, using imagery, using, a snippet of an audio that I've translated or transformed, excuse me. Any of this can start to kick in. And now what we're going to dig into in this query pipeline is doing a couple specific methodologies. So the first thing is just, right, thinking about how this actual search is looking at. It's a little more complex, right, than just a single arrow. So we wanted to talk about what this is going to do when I have this in place. So we now are going to be able to pull out our data source, right? And this is where I'm using clip. This can now start to abstract into the use cases we were talking about before. This is my social posts. These are my logs. This is all of the videos on my streaming site. This is all of the imagery that I've taken from CAT scans. Fill in the blank, right? There's a tremendous amount of capabilities that is unlocked in this data. Now, using Pinecone, right, I'm able to both apply the metadata that we have, and this can be various different things. I've seen some good questions already that we'll dig into, but how do you start to extract a label? This is really where I can go and apply the labels that I have to work with. Maybe these are metrics about pieces of data that are interesting to me as a business or interesting to me as a model developer. And then, right, we can start to think about unstructured data and truly the most unstructured data being unlocked by these embedding models and being unlocked by these vectors. So now I have data that has historically been really blocked. And again, not blocked per se for humans, but it has been really difficult and challenging for developers, for machines, for computers to really start to dig in and use. So if I can take this process and take truly unstructured data and start to search it, this becomes very valuable. And now what Gibbs alluded to, and where we're translating this back, is when I need to curate data for an autonomous car, I'm not doing this on dozens or hundreds or thousands of vectors, right? I'm doing this on millions and billions of vectors that are changing every day, that I'm collecting every day. And so the searching aspect of this is not just about finding the right data, but doing this at such a unique and complex scale that this is really where Pinecone is saying, hey, there's a unique place where you can simply do search and get these results across this large data and get value. The first kind of place where you can start to really use the search as itself to get value, right, is in this classification. As a mechanism, when I start to search for the nearest and most similar data, right, I'm going and jumping to the right clusters, as Gibbs talked about the algorithm, and now I can use that query to really start to classify what the new query is. And this is a true zero-shot kind of perspective, but much more interesting than just saying, hey, what is this piece of data? This is all in a workflow. So if I am building, right, a defect detection algorithm and I have this at the edge, we're going to have an offline training process where we're going to start to see new defects as new products roll out, right? So what I can do is I can go and I can see, is there any older defects that are very similar to this new one? that we had an appropriate process to take control of. Right, we are going through and we are classifying this new defect with older defects to find whatever the relationship is there. This is exactly how people are starting to use Pinecone and have been using Pinecone for, quite frankly, it's for, its entire kind of timeline is with, the anomaly detection is saying a vector index is going to put my data in the right positions for me to be able to access it. If there is an anomaly and it's distinct from where these clusters are, I can trust that and really be able to move on with my process and start to work on building the application. So Gibbs and I really wanted to leave about 15 minutes for Q&A. So we're right at time here. So I'm going to just do a quick conclusion and open this up. I know Vamshi has been doing awesome answering all the questions, but we can go through them. So just some real high level key takeaways that we wanted to talk about. And this is, again, a very high level first session where the goal of each further session of this is going to actually dive into these use cases and try to look at what it will take to do these. Right now, we wanted to look at what is going on in this landscape. What are these different use cases? How we can think about them? What parts of these use cases Pinecone helps with? And the key takeaway, right, is when you're working with tremendous amounts of data, curating data, trying to zero shot classify it, find right pieces of information, find anomalies, find edge cases. You have to do this across dynamic data that is large, it's evolving, it's super diverse. And this, if you can understand that your AI problem has these pain points, there's a really, really, really good chance that implementing these vector search techniques is going to have a positive impact here. So with 15 minutes left, Gibbs, I know we can bring it over to Q&A
Yeah,
here.
and I was gonna say, I think we've had a lot of questions coming in through the Q&A part of the webinar, which is great. And Vamshi, thank you for answering all of them. But if you still have questions and want to ask live, now that we are done with our slides, just raise your hand and I can unmute you and you can just ask directly to us. Okay, hold on, we got one. 1 second. All right, Bob, you can speak.
Thank you. Can you hear me?
Yes.
I don't see any answers in the Q&A to any of the questions. I asked 2 of them. I don't know if I can repeat the questions here for others, but perhaps you could point me to if there's any answers. I can go read those, but I don't see any answers to any of them in the Q&A itself.
Okay.
Well,
I do see that Vamshi answered one of them in the Q&A. Maybe both of them. So do you want
I'll read my 2
okay.
and you can choose if you want to answer either or
we
both.
we definitely
The
do.
first
Sure.
the first one is, how do you obtain metadata from an unstructured data set? And then how do you combine it with the data itself into a vector search to optimize results versus doing a vector search on the data set alone? So that was question 1. Would you like me to read question 2? Or do you want to answer that first?
Let's do question 1, and I think it's a really awesome question, Bob. And right, there's a lot of different ways. So first and foremost, there are some capabilities to help start to do this with Pinecone, and then there's other tools that we've seen that we're partnered with in the market that help. So a lot of ways you can take a truly unstructured piece of data. You would have to label this piece of data, which maybe would get, a human being involved who's a subject matter expert to apply a concept. We're also seeing that the use of transformers over the last 5 to 7 to 10 years has been huge in actually helping with that. So instead of taking just a pure raw piece of data and starting there, I can take a raw piece of data and ask a model like ClipSeg to predict where certain instances of something are, or to classify this, or to give it a sediment. And then furthermore, what we're saying with how you can use Pinecone is if you store this unstructured data in Pinecone, right? It's going to be clustered natively. So if you have ideas of information you want to extract from the unstructured data, you can use a multimodal search, whether that be the actual kind of thing you're looking for, or, you know, a piece of text of that, and pull a top K, where then you could apply the metadata with Python or something like this, and then keep searching on that. I can, if you have an email, I think Vamshi and I, we can follow up after, and I can send some resources of some partners too from us that would help here.
That would be great. I did, when I registered, provide the email, but I can do that separately. The second question is, as background to this question on document search, I've seen no-code solutions. They're very good when all of the information is stored in a single document. But if you ask a question that cuts across multiple documents, the performance basically goes substantially down. So here's the question. If the goal is to search a large number of documents where the relevant information to a query is located in several documents, how are this is about the clustering. How are the documents clustered, or segments of documents clustered, such that that search that you showed graphically can get relevant information from, you know, a significant number of documents, whether that's 5, 10, or 20 documents? So it's about the clustering technique, I guess.
You're muted, Chris.
Yeah, awesome question, Bob. So from a super simple answer, when you provide a query to Pinecone, right, you're providing the vector, and what Pinecone will do is it will go through those clusters, and it'll basically take a hierarchical, and I can't pronounce that word, so I apologize, IVF approach, where it's going to say, hey, what clusters is this most similar to? And we look at a centroid of the clusters. And then what I can say is, okay, it's similar to this query is similar to these 15, 20 clusters. And then I can look through each of these. And even if that answer is in document A, document B, document C, document E, right, all the way to N, that's somewhat insignificant. Rather, if it's similar in the clusters that the query vector is approaching, it will pull this out. And from a separate answer, Pinecone has tooling around this in what we call Canopy, where you are or able to very efficiently do that. And just by a native kind of ANN query search, it will try to capture that information. It's a really great question, and we can provide a little more info on Canopy, which shows this in a really decent demonstration.
Thank you. The micro follow-up on that is, when you're doing your clustering, you don't know a priori all the questions that the user set's going to ask. How do you know how to cluster? I mean, it's a high-level question.
Totally. So at the end of the day, it's, you know, you're clustering based on how similar the actual vectors are of what you're putting into that index or that cluster. So even if, you know, you're getting ready for these questions, what there's a lot of work on outside of just clustering this information would be, how do I rewrite one of these queries? How do I do something like that to then be able to drive into that?
Thank you very much.
Yep. All right.
Thank you for joining.
Sure, yeah, great questions. And I know we have a few more here, so I want to turn it over to Martin West. I have handed you over. Yeah.
Thank you, Gibbs. Christopher, a bit of a follow-up on Bob's question. You mentioned dynamically, semantically grouping the data and storing it and making it adaptable to ongoing changes in the data set. Can you talk a little bit about that?
Yeah, Gibbs, do you want to take that one too? Just from the pure freshness layer, I could take this one.
Yeah, sorry, do you mind just, I was responding to something else. Do you mind just repeating the question?
Yeah, sure. The question was, you had mentioned that the chunking strategy or the storage strategy was to vector within dynamically semantic groupings.
Mm-hmm.
And as the data set evolved, that would be fully adaptable. which sounds amazing,
Yeah.
given where we're at today most
Yep.
of the time. So
That's awesome.
that's more, yeah.
First and foremost, I love your Zoom background photo too. That's a great, that's refreshing. It's a cool one. But yes, so as the actual Pinecone as a core product, as a database, right, is going to have two capabilities that are really going to help around this. The first one is going to be that the algorithm that we talk about allows us to only need to update or reinsert or change certain parts of the data and somewhat disregard the data that we don't need to change. So this means that we need to use very little compute to actually go in and put all of this in the right way or come and query this as this data changes. And then furthermore, from another capability, you have what we call, right, this freshness layer, which is when as new data comes into the system right away, it's stored immediately for the team to query. So as data is changing and impacting, query time is at 0 second that you can pull out. So those are the two capabilities around the actual algorithm of upserting and querying, and then the freshness layer creating this for freshness.
So how are you deciding to make the groupings, the semantic groupings together? Like how are you, is that part of the data structuring activity?
Yeah, that's I would say like it's I guess a mediocre answer, but that's like the Pinecone IP, would you say, right? But that's really around the actual like math and algorithmic fine tuning that we've done around building out this type of search algorithm. So the way that we decide to cluster is really looking at the data that is being, presented, right? The new data, and is looking at where it's similar in the index that has already been built, and then doing a similarity search to place that in. And there's a bunch of kind of secret sauce underneath that to do that there. That makes sense.
Yeah, it does. Thank you.
Thank you.
Okay, I think we have one more hand up. So Cooper.
Oh, thank you. Yeah, how do we update vector database effectively? The one way I know we could use metadata, but end up having another SQL database just to manage this metadata. And I ask this because there could be a lot of documents that gets outdated, our data that had mistakes, and I find it very difficult to go into vector database and figure out where to update, delete, or even, so just wondering from the expert here, how do we do that effectively? Yeah.
Cooper, it's a great question. And first and foremost, I would say that, it depends to a lot on the use case that you're working on. So some of the data that you're talking about, might not be represented perfectly as metadata in Pinecone today. And I think that's definitely where we've seen a lot. But around the CRUD capabilities, I think the metadata that you can use, you can start to use super creatively. And then also around peer partitioning. So you can set up your Pinecone index to have all these different namespaces, which are, you can think about an index inside of an index or a project inside of a project. And then from those certain projects, you can then start to add different metadata features into this. If it's true structured data, well, then there's an approach you can also take with this multimodal search, where you can treat that as what we call a sparse vector. And I'm not sure if you've heard of any hybrid search or sparse boosting. Semantics are slightly different there, but what that does is it takes the information, think about structured information relevant like that, and places a sparse embedding, which is a combination of 0 and 1s to represent that, and combines it with the unstructured embedding. So that way you could start to do keyword search and other capabilities that would give you more capabilities with that type of data. So if that answers the question slightly, Cooper, I hope it does.
Yeah, it answered partially. I just want to say if I have a document that has a mistake and I'm going to delete that in vector database, it was very difficult for me to pinpoint exactly where the mistake, the data contains the mistake in a vector database. In the SQL database, I can do select, and that was easy. But in vector, it's almost like black box. So I hear what you're saying. We can do better namespace, but that's a cost of all the documents together. So I become, I have to do a lot of manual labor to actually re-observe all the document and delete the namespace and recreate like that again. Just wondering if there's any way have surgically very pinpoint to the data I want. I know where it is in the dimension, or if it's even possible. Yeah.
Yeah, it's definitely possible in a lot of days, especially if you're looking at a RAG type of use case, right? You can use the doc prefix and chunk IDs and then query or select these or simply fetch these here. And when it looks at some other types, we're seeing a very similar process of that. But maybe this is something that we could chat on actually offline for a little bit, just to better understand what your use case.
Yeah, I'm a RAG chatbot, and that's precisely the kind of issues I'm facing. But yeah, thank you very much. Hello, Pinecone.
Thank you for
Awesome.
joining.
All right. Okay, one last question, and then I think we're gonna need to wrap up. We can always do more offline as well. I'm gonna turn this over to Siddhant.
Hello.
Hello.
Hi. Wait, can you guys hear me?
Yes.
Okay. Well, the question I had is, I was wondering if you guys are ever going to drop something in like C or C++, because right now I'm only building apps for Apple. And so like that's why I was thinking. And then the reason I was asking about LTS questions is because I'm like apps, like you're right, you should focus on both platforms, like both the Android, iOS, but just from a user standpoint, like React Native is horrific to set up. Like I'm very experienced in React and TypeScript and stuff, and so like my worry is like, suppose eventually you come up with building like custom apps on both platforms. Like, do you think it's a header file or something, or should we just run our own servers and like do it in the back end, or yeah, like use serverless? Because my issue with serverless is it's just it like becomes extremely expensive long term. And I'm a student and I only have like 10K in AWS credits. And so like just thinking about the scale of users, like 1 user, 10 users, 100K users, like long term, if we're thinking, a decade down the line, which that's because I'm 18, so I'm thinking a decade. I don't know. It's sort of a lot of information to like load into one question, but the question is like, like specific native support for like iOS, specific native support in like Go. That's sort of what I was wondering.
Totally. And I would let us follow up with you. I'll follow up with you offline if you don't mind. I can chase down a couple answers specifically, and then I can help you kind of think about the best way to set this up for now and the future. And
Okay.
with some serverless things here, we can definitely play some cost-effective games. We're seeing really, especially for getting started, just being really cheap here. So let me connect with you. It's super exciting that you're building here, and I'll follow up.
Awesome. Thank you so much.
Yeah, thank you for joining.
Yeah. All right. Well, I think we're at time now. So thank you so much for everyone for all the questions. There's a lot of great questions that came through. Obviously, there's a lot more that we could spend time here talking about, but we'll make sure to send out the recording, post it on our YouTube channel. And yeah, keep an eye out for additional Bits and Bytes sessions in the coming weeks, coming months, more on classification. And yeah, thanks again. Have a great day, everybody.